Okay, before I kind of demonstrate overloading operators, I'm just going to review a class called the fraction class. And it's a pretty standard class. It has two data members, numerator and denominator, because if you know what the numerator is and the denominator is, then you know what the fraction is. It's got a default constructor. It's got a constructor with parameters. It has a set numerator and set denominator function, and they are written inline. It has get numerator and get denominator functions, which are written inline. It's got a fraction to decimal function. It just converts a fraction to decimal. I'll show you the code for that in a minute. And then it just displays a fraction. So that's what's in the class. Now I'm going to look at fraction.cpp. So our default constructor sets a fraction to 1 over 1. You know, a lot of times we use 0, but you wouldn't want to use a 0 for a denominator. Here's our initialization constructor, or the one with parameters. It'll pass n into the numerator and d into the denominator. And this just converts a fraction to decimal, which is the numerator divided by the denominator. Now keep in mind, in the header file, these are both declared to be integers. So if I just divide them, right, like this, it's going to give me the result of integer division. So if it was 1 divided by 2, it would be a 0. So I need to use a static cast on either the numerator, or I could use it on the denominator, or I could use it on both. But this will convert the numerator to a double and then divide it by the denominator, which will then be promoted up to a double. And my display fraction just displays what's actually stored. The numerator is and the denominator is. So right now, I've just got a couple of fractions declared here. And I'm just going to do this. Okay, just so you can see what's stored out there, right? I'm going to run it. And then it says 1/2. Fraction 1/2 is the numerator is 1, the denominator is 2. So the first thing I'm going to do is just come in here. I'm going to just fix this so it looks a little bit more like a fraction. So I'll put a numerator, then a slash, then the denominator. Kind of like that. And let's see what it looks like now. Fraction 1/2 is 1/2. Okay, that looks much better. All right. Just a couple things. You could just put numerator here. This is a member function. It has direct access to the data member. So that would be fine there as well. It's kind of personal preference. Okay, so right now, I think what I'm going to do is I'm just going to display the 3 fractions that I have declared up here, you know, using their constructors. And what's the last one? 3/4. Okay, so now I'm going to run it and just, you know, I should have 1/2, 2/4, 3/4. Okay. All right, so now we have that in order. We're going to talk about overloading operators. The idea is in C++ we have some standard operators that we use for everything. If we want to output an integer, we might do that. And if we want to output a double, we might do that. And if we want to output a string, right, we can do that. But what we're doing in all these cases is we're using the output operator to display whatever follows. What would be nice would be if we could do something like this. So if we could use the output operator with our fraction class, right now I can't. But what I can do is I can overload this operator by writing what's called an operator function, and it will get that operator to work for the fraction class. Okay? Or let's say I wanted to do this. Right? We know what that would mean. Multiply two fractions together, right? Because that's what multiplication means, and store the resulting fraction, right? In this fraction result I have declared here. We can't do it yet, but if we overload the multiplication operator, we can get it to work for a fraction class. Now, there's some rules for overloading operators. First of all, you can only overload existing operators, so you can't make a new one. Like you can't make, you know, let's say you want to pick a whole new character, like the add symbol, and make it an operator. That doesn't work. So you have to use existing operators. There's some operators that cannot be overloaded, but they're not the standard ones. They're like the ternary if operator, which is a colon question mark. Let's see, the dot operator, the size of operator. There's not really standard ones, and they are explained in the Revel book as well, which ones you can't do. And you shouldn't change the purpose of an operator. If you're using multiplication, it should be multiplying things together, because you could make an operator that actually, a multiplication operator that adds two things together, but that's not the intent of overloading operators, so you should not do that, okay? So this first video was just introducing the class, all right, and talking a little bit about what overloading operators actually means. And I'll explain one more thing now. I'm just going to make a comment over here. What happens when this section of code gets executed is the following. The compiler calls a member function with F1 called operator star, and it passes it F2. So this executes a function call. F1 calls the function, right? The name of the function is operator followed by the actual operator, which in this case is star, and it passes it the right-hand operand. So what we have to do to get this to work is we have to write this member function right here. Okay, so in the next video I'll continue with that.